were talking about, we solved systems of two equations with two variables, and we had three ways of doing that. Do you remember what those three ways were? What's one of them? Substitution, elimination, and graphing, right? Where we actually draw them out, excuse me, and see where they intersect. All right. So I'm going to kind of set us up from our past work and lead it into today. I don't want you to write anything I'm about to write on this blank screen. Okay, you can just put your pencils down and just give me your eyes and your ears. And by the way, so we're all clear, I'm about to just throw some numbers up here, and the math's not going to be correct. Okay, so just breathe. It'll be okay. The numbers won't match. It's just for illustration purposes. All right. All right. So let's say we had something like this last quarter before spring break. Okay, a system of two equations with two variables, and we want to solve, right? We could solve by substitution. We could solve by elimination. If I wanted to do elimination, and by the way, the reason why we want to do that is because when there's two different variables in there, we can't solve. Like, we could shift stuff around left to right, but we would never actually get anywhere. The only kind of equation we can solve is when there's one variable in it, and just numbers. So here our goal was to eliminate one of the variables. So let's say I wanted to eliminate the x. I might multiply this by -2 and add it to the above equation. I don't really know what that's going to give me, so don't freak out. That's not going to be correct. Don't do the math in your head. But I do know the x's would drop out, and I would have some kind of y's, and I would have some kind of numbers, right? And I would be happy about that, because I would just have the one variable left, and I could solve. Right? And I would solve, and I would plug it back in to get the other one. However, today we will have not just two equations with two variables, we're going to have three equations with three. So let's say I had something similar to that, but with a third variable. So let's say we had something like that. And I was going to do the same thing and do that multiply by -2 step. So let's say I was looking at these two things, and I was going to multiply by -2. Okay, and then I would add those two equations together again. Well, the x's would drop out, just like they did over there, but I'd still have some y's, and I'd still have some z's. And can I solve this? No, but because there's too many variables, right? However, if I picked a different two equations, like I did that on the first two, but what if I canceled x out of the second two? If I did some kind of math to cancel the x out of the second two, I'd still be left with some y's and some z's and a number. And then what could I do with that? What can I do with those two things? I would just do everything again, right? Use substitution or elimination. Again, one more time. And then what that would do is drop you down one more variable, and now you could solve, right? So really, it's just a double-sized serving of elimination. And you're just going to do it a few times. And so that's what your notes are there. So all these words right here on your notes basically say that I kind of talked about. And I'll go through, and I'll bring your attention to the steps as we do them in the example problem. But they're all here for you to read again at your leisure. So it's supposed to be leisure, but they say leisure like in other countries, and I think it's funny. All right, so we have this example right here. But what's up about this one? Like, I just went through all this trouble of telling you about equations and three variables, and this is our I will statement. What's up with this one? Yeah, there's only one z. That's exactly right. So what's going on here with this one is kind of a lot of the work is already done for you. And we'll do that work in a minute with our second example, but this is kind of just like we're going to edge into this slowly. So what I want you to write into this problem is, to begin, I want you to write that we're skipping to step 3. So that way, if you go back and look at your notes, you'll know why we kind of skipped some stuff. Right? So if we're skipping to step 3, let's see what step 3 says. Gabriel, read step 3 for us, please. Thank you, sir.
Solve a system of 2 equations and 2 variables you created using either substitution or elimination.
Okay, thank you. So solve the system of 2 equations and 2 variables you created. We didn't actually create them because it's already done for us in this problem. Which 2 equations are the system of 2 equations with 2 variables? The last 2, right? Okay, so we're going to start there. We'll create them ourselves in the next example, but for now, they're already done. And I'm just going to call these R1, R2, R3. The R just stands for row. We'll use the same notation when we do matrices. It's not required, but it'll be helpful for you to understand my notes. So we have this system here, R2, R3. So step 3 says to solve that system. How many of you like elimination? And how many of you like substitution? Does anybody prefer substitution? Okay, you can do whichever way you like. I prefer elimination, so I'm going to go with that. But you're welcome to do substitution by yourself on your notes. You'll get the same answer if your math is good. So if I'm looking at R2 and R3, my next step, so I have to solve this system. Which of those variables is easier to eliminate? The y is, right? Because in row 2, there's no coefficient in front of it. Also, they already have opposite signs, so that's a good setup. So what kind of math do I need to do to get the y's to eliminate? Multiply by 2, perfect, on that second row, right? So this is what I'm going to do. Okay? So I'm going to do 2 times row 2. I'm going to add it to row 3. So 2 times row 2 gives me 8x plus 2y equals 2. And row 3 stays the same. And so we add them, the y's cancel out, and I'm left with 5x equals 10. What do I love about this equation? How many variables are in there? 1. I love that, because I can solve it, and there's no additional work for that variable. So divide both sides by 5, and we get x equals 10. I'm just going to circle this and leave it on ice for a bit. So I'm going to hang out there. So that's great. We know that x equals 2. This system that we started it, now that I know that x is 2, what's the next variable that I can solve for? Y, right? Because that was in x and y. It doesn't always have to be that way. It could have been x and z. But in this case, it's x and y. So I'm going to take that x equals 2 and plug it into one of those. Which do you like, the second one or the third one? Second one? All right, me too. So that gives me 4 times 2 plus y equals 1. And this begins our 4th step, which is called the back substitution, where you just start substituting back into the other equations to get your new variables. So if x is 2 and I plug it in, this gives me 8 plus y equals 1. Subtract 8 and I have y equals negative 7. Which is wonderful, but which variable do I still need to find? Z. So I take these 2 things and plug it back in where? The very first original R1, because that's the only one with the Z. Okay. So I take x equals 2, y equals negative 7, plug it into the original, negative 2 plus negative 7 plus 5z equals 1. Negative 2, negative 7 is negative 9. And you add 9 to both sides. 5z equals 10 divided by 5. Z equals 2. Step 5. Vianney, read step 5 for us, please. Step 5, please. Okay, thank you. So in the last couple of lessons, we were like, ordered pair, ordered pair, ordered pair, ordered pair. And we hear that phrase so much, we think that every point is called an ordered pair. But what does the word pair mean? Two. So we only say that when we needed x, y. Here I need three things. So instead of calling it an ordered pair, it's an ordered triple. It's basically a point, and it's always going to be in this order, x, y, z. And one thing I want to sort of drive home right here, this happens to be the exact same order we solved in. We found x first, and then y second, and z last. That's a coincidence. That is not a rule that will happen every time. So if you're solving a system and you solve for z first, don't freak out and think you're doing something wrong. That's fine. Just be careful when you go to write your final answer that you put z in the last spot, not the first spot, just because you solved for it first. So it's not the order which you solved, it's the x, y, and z values that you got, okay, regardless of the order. Okay, so this was like a little baby intro to the way you solve a system with three equations, okay? Still kind of a lot of math. Now we're going to add some more math. This right here, so we skipped to step 3. Does anybody need this up anymore, by the way, before I change it? All right, so for the next problem, we're not skipping to step 3. Right? If you look at this system, it's got all of its variables involved. So what our sort of pre-work here is to find one variable, eliminate it 2 times. If you eliminate only one variable 2 times, you'll get something like this with the 2 equations and the 2 variables. Once we do that, we can then do all this. Right? So if you're looking at your steps right here, step 1 says make sure all of your equations are in standard form. So look at that system and tell me if you think yes or no, everything is already in standard form. Yes, absolutely. Okay, so step 1 is done. Step 1, done. Bianca, please read me the very first sentence of step 2, not the whole thing. I just want the first sentence. All right, thank you very much. So select a variable to eliminate. We got 3 variables to choose from. We can do whichever one we want, but hopefully you want the one that's going to cause the least amount of math. So take a minute and look through there, and don't holler out loud, but take a minute and just think which of those variables would be easiest to start eliminating, that would require the least amount of work from you, and just raise your hand when you have that in your brain. Okay, thank you, thank you, thank you, thank you, thank you, thank you, thank you. Who thinks X would be their place to start? Y? Z? I think the Y's have it. But just to be sure, does it matter where you start? No. But we're going to start with Y. And here's why Y is a great place to start. You see these 2 right here? They automatically cancel each other out. So again, we're trying to eliminate one variable. So we've chosen Y. So we're going to eliminate Y. I'm going to put some symbols here, and this will become more apparent to you in a bit. But for right now, just trust me. We'll star those 2 things because that's where I'm starting. Row 1, row 2, row 3. So my first step I'm going to do, this is my star work right here for those 2 equations. I'm going to add them together. The y's cancel. You add your x's, you get 5x. You add your z's, you have 1z. And then 3 minus 1 is 2. How many variables are in that equation? 2. So I can't solve it yet, right? But at least I've lessened the amount of variables I have to work with. Like I'm making forward progress. The goal is to eliminate all of them and solve for them. Okay, so this was the beginning of step 2. Select a variable to eliminate. Dylan, please read me the next sentence. on step 2?
Use two different combinations of any two equations to eliminate that variable and create two equations in two variables.
Okay, thank you. That was a lot of words, right? Here's what it's saying to do. Use two different combinations of any two equations. Well, I've already done this combination, 1 and 2. And which variable do we eliminate with those two? Y. So we need to eliminate y again. It's not going to do me any good to use the same two equations, right? So I need a different combination of two equations. That could either be these two, row 2 and row 3, or row 1 and row 3. It just has to be a different combination. Okay, that's all that part of that step is saying. Which do you think I like? The bottom two, okay? So I'm going to use a different symbol on those. So here's why I'm even doing the symbols. Because it's real easy, even if it's just 3 things, but it's real easy to get mixed up where you were and what you're trying to do now. So that's why I starred the first two, and now I'm going to use a different symbol for those two. I'm going to do the work down here. I'm sorry, this was like 2 years ago. Which variable are we eliminating? We're eliminating y, all right? So I'm using these two equations. Here's the y's I'm trying to eliminate. What math do I need to do to get those to cancel out? 2 times which row? Row 2, right? 2 times row 2. So I'm going to take 2 times row 2 and add it to row 3. So that gives me 8x minus 2y plus 6z equals 6. And then I'm adding it to 3x plus 2y minus z equals 4. So the y's are gone, which is what I wanted, and I'm left with 11x plus 5z equals 10. And that was just step 2. We chose 2 different combinations of 2 equations to eliminate the same variable. By 3. No, that would be fine if you multiplied this one by 3 and then this one by 3. But what would that cancel? That would cancel what out with what? You mean from the original system? I don't think so. I think I'm probably not understanding what you're saying. Because if I had a 3 here, right, that doesn't cancel the y's out. You mean if you added all 3 at one time? Oh, let me see. Let's try that. If you canceled all those y's at one time, that would be 12. You'd still get one equation with 2 variables, and you'd be kind of stuck. Because how would you generate another equation in 2 variables? Are you following me on that? But I like that was a good thought. I like that thought. Now that would really work great if somehow by a miracle you happen to have canceled out 2 variables at one time. Then you just have the 1 variable left and you could solve. On and on. Okay, good question, good question. Thank you. Okay, now I got to get back in my, where was I? Oh yeah, so now we are in step 3. We have this system of 2 equations and 2 variables right here. So now this is where we began the last problem. So all that work we just did only got us to being able to do this now. All right, the last problem. So we have this system. We have 5x plus z equals 2, and 11x plus 5z equals 10. Take a minute and solve that system, please. You can use substitution. You can use elimination, whatever you like. Just you take a minute and solve for x and z. Okay. It's a Monday after spring break. I get a pass. How did you begin solving? Which variable did you eliminate? The z, right? So you did negative 5 here, which gives you negative 25x minus 5z equals negative 10. Cancel, cancel. Negative 14x equals 0. So that makes x equal to 0, right? You divide both sides by negative 14. So x equals 0. All right. So that's great. If x equals 0, and I've got two other variables to solve for, which variable is the best one to solve for next? The z, right? Because of this system right here. So remember, you don't have to solve for y next just because it goes x, y, z, and just because the example problem went x, y, z. You go in whichever order you need for it to work. So this system that we just solved for was x and z, but now I know x is 0, so I'm going to plug it back into one of those equations. Which one do you like better? Top one, me too. So plug it back in. So I've got 5 times 0 plus z equals 2. 5 times 0 is a 0, so z equals 2. And what's the last variable I need to find? Y. Where do I go for that third variable? One of the top equations, okay? Any of the original 3. Which ones do you like? Second one? Okay. So, I'm working. What are you doing?
Do the report thing for...
Oh my gosh, no, I haven't thought about that yet. I still have some grades I have to enter in a project. I'm going to do it in my 8th grade. Do you guys have it done by a certain time?
I think we're supposed to... I would have think like...
They said grades were finalized by 4, but...
Well, I was just thinking...
Oh, no, I haven't done it yet. Thank you. I have a few more grades I have to fix.
I'll help you with it.
Okay.
It's not hard. It's just one of those things where you're like, what?
Okay. Thank you. Blah, blah, blah. Did you already solve? Which one did we say? The second one? First one? This is where I get all teacher and be like, does it matter which one you do? Doesn't matter which one you do. So this is our back substitution, which we already kind of started right there when we plugged it back in and we got z equals 2. So first one, x plus y minus 2z. Okay, so I know x. I don't know y. Minus 2 times z, z is 2, equals negative 1. I feel like I did something wrong. Did I get that? 0. Y minus 4 equals negative 1. Add 4, y equals 3. Is that what y'all got? Okay. And how many of you stopped right here and did not write your answer as a point? You don't have to admit that to that if you don't want to. Please tell me, I'm going to write the wrong answer, and I want you to analyze what I did and tell me what I did wrong. It's out of order. What was I thinking, though? That's the order that I solved it, right? So I need to be more careful than that, and I need to put it in x, y, z order. So I have to think for just a second. Okay, x was 0, y was 3, and z was 2. Now, I want you to take a few minutes and try the next problem all on your own. I mean, you can work with your neighbor, but I want you to just carefully go through the steps and just see what you come up with, okay? And it's okay if you get something wrong. It's okay to erase and have to stop again. That's how you learn. So you did 2 times row 1, adding it to row 2. So that gave you 6x plus 2y minus 4z equals 6. And then row 2 here. And then when you add, the y's canceled, and you got this, and you're like, yes, everything's looking exactly like the example did, right? You got this equation with 2 variables, and we were good. So then you picked a different 2 equations, and the one that I saw, most of you picking, I think you did 4 times row 2, negative 4 times row 2 added to row 3, right? So y'all chose, most of you chose this one right here, and here's what your math looked like then. So this is the heart work, this is my star work. So negative 4 times row 2 plus row 3 looks like this. And setting aside just a few arithmetic mistakes you made, what you noticed was that the x's cancel, and then you got this. And then right here, you were like, okay, I don't know, that's different. Right? And you stopped. But it's actually easier than the other one, because it's okay that it doesn't look exactly like the example. Just breathe for a minute. What do I like about this thing right here? It's only got one variable. And so when you solve, you divide both sides by -7. You get z equals 5. And you might feel like, well, you're still stuck. However, look at this equation that you just did in the star part. How can I use that z equals 5 here? Just plug it in and solve for x. Right? So 7x minus 5 equals 16. You add 5 to both sides. You divide by 7. X equals 3. Okay, so this is our back substitution step. And then just take both of those and plug into one of the original equations. Which one do you like? First one? Okay. So the first one gives me 3 times x, which is 3, plus y, which is not 5, plus y, which is just y, minus 2 times z, which is 5, is 3. Do your math. 9 plus y minus 10 equals 3. 9 minus 10 is -1. Add 1 to both sides. And y equals 4. Okay. And so your answer is 3, 4, 5. By the way, this is a Pythagorean triple, which means if you plugged it into the Pythagorean theorem, it would work. 3 squared plus 4 squared equals 5. You may have your phone.